Today we will continue with hypothesis testing, and we will focus on left tail test. Okay, for the right tail test and two tail test, you can refer to my previous lessons. And now we will take the past year questions as example. So let's see the question 1 from May-June 17, variant 71, question 2. Past experience has shown that the height of a certain variety of plant have mean 64.0 cm and standard deviations 3.8 cm. During a particularly hot summer, it was expected that the height of plants of this variety would be less than usual. Okay, so when I'm reading the question until this sentence, I can tell this is a left tail test. And how do I know? Because of less than. Right, this indicates that the H1 is going to be less than. Now, in order to test whether this was the case, a botanist recorded the height of a random sample of 100 plants and found that the value of the sample mean was 63.3. And this is the sample mean. Okay, stating a necessary assumption, carry out the test at the 2.5% significant level. So now, the first thing we need to do is state the necessary assumptions. Okay, and the answer is, we assume that the standard deviations is still 3.8 cm. So this is the assumption made. Okay, now we got to define the random variable. First step, and it has to be the X-bar distributions, and X-bar distribution follow normal, where the population mean given should be 64 cm, and as we assume the standard deviation remains the same, 3.8 and square, and since we are looking at sample mean distributions, don't forget that the variance must be divided by sample size. All right, so that is the first step. We define the random variable. And now we have to determine the null and alternative hypothesis. Okay, as what we can tell, supposingly the mean height should be 64 cm for these types of plant, but due to the hot summer, it's expected that it's less than usual. So which is less than 64. Okay, now we have to determine the critical region, and to get that, we must have the significant level given. And in this case, given to be 2.5%. So I will reject H now if the z-score. So what is the value of the z-score? Let's see the bell-shaped curve. And since this is less than, then it has to be on the left side. This smaller region, which is the probability, equals to 0.025. Okay, and what are we going to get? The corresponding z-score to give you the probability 0.025. So we have to refer to the table. So I will scroll down and have a look at the table here. Right. Of course, when we try to look, we won't get the probability to be 0.025. We must take 1 minus 0.025, and which is 0.975. Okay, from the smaller table below here, we can see 0.975. When the P is 0.975, the corresponding z-score is 1.96. So that is what we want. Then we will go back to the questions. And you can tell, since this is a z-score value that lies on the left, is going to be negative 1.96. Right? So we will reject the H now if the z-score value found to be less than 1.96. Now we have determined the critical region. And now we go on to the next step. Calculate the test statistic. So which is going to be the sample mean. What is the sample mean? 63.3 given by the questions. 63.3. Then minus the population mean divided by the standard deviations. Divided by square root 100. Okay. Calculate this value. The z-score, the test statistic found is negative 1.842. Okay, so obviously, since the z-score value found is greater than negative 1.96, which is not less than, hence we do not reject H now. Right? So the E, we have already done the comparison. We compare with the test statistic with the critical region, right? And now we get to make a decisions. So we do not reject H now. Then there is insufficient evidence at 2.5% significant level. Significant that. So what does it want us to test? So we want to see whether due to the hot weather, hot summer, the mean height of this plant would be less than usual. So our conclusion is that the height of the plants of this variety would be less than usual, is insufficient. That the height of this variety is less than usual. So we have insufficient evidence, so it is not less than usual. All right, so the mean height would stay at 64 cm. Okay, so that is a left tail test. Again, how do I know it's a left tail test? Because according to the questions, is suggesting that the height less than or smaller than. Okay, so this is the left tail test. So now we are going to look at the next questions. Okay, this is the question from November 2002, and it was called the paper 7. Okay, from previous year's observations, the length of salmon in the river were found to be normally distributed with mean 65 cm. A researcher suspects that pollution in water is restricting growth. Okay, so can you see? It used to be the mean of the fish, the salmon fish, to be 65 cm. But the researcher finds that maybe due to the pollution, it is restricting growth. Restricting growth, isn't it, means less than? Right? So this is also a question about left tail test. Okay, less than. Now, to test this theory, she measures the length x cm of a random sample of n salmon and calculates that the sample mean to be 64.3, and this is the small letter s equals to 4.9, and is explaining to you that the small letter s squared is the unbiased estimate of the population variance. Okay, then she then carries out an appropriate hypothesis test. Okay, now part 1. Her test statistic, Z has a value of this negative 1.807, correct to 3 decimal places. We need to calculate the value of n. So from my previous example, we know that to look for the test statistic, we just have a formula, right? Which is the sample mean minus the population mean divided by the standard deviations. And in this case, it's given by the small letter s, the unbiased estimate of the population standard deviations, and square root the sample size. So it should be equals to negative 1.807. And hence we sub in the value. Do we have the sample mean? Yes, 64.3. What is the population mean? 65 as given by the questions. And then do we have the standard deviations? 4.9. Yes. And divided by square root of sample size is what we need to determine. Okay, so we calculate out the value of this small letter n, and we will be eventually getting the n to be 160. So the sample size is 160. Okay, done with part 1. So now we are moving on to part 2 using this test statistic. So which means we are going to use the z-score negative 1.807, and then we try to carry out the hypothesis test at the 5% level of significance and state what her conclusion should be. Now, if we are going to carry out hypothesis test, so important thing is we must have the H noun H1 listed down. So supposingly, the length of the salmon should be 65, right? But from the sample of 160 fish, the 160 salmon fish we get and measure, and we found the mean length to be 64.3. And because the researchers suspect the pollution restrict growth, so the H1 to be less than 65. Okay, and what else given? Significant level given to be 5%. So I need to determine the critical region. Restrict H now if the z-score. So now same thing. So again, since this H1 stating less than, we will look at the region on the left, and where the probability is 0.05 due to the significant level. And what is this z-score value? All right. So in order for us to get, again, we need to read from the normal distribution table. And if you are going to read, you will not be able to get the probability to be 0.05. You have to take 1 minus, and you have to read 0.95 to look for the corresponding z-score. So, usually when we talk about significant level, I will try to look at the smaller table here. If I don't get the probability from smaller table, then only I will read from the big table above. So since I managed to get the corresponding z-score, 1.645. Found. Okay, now I come back to the questions. The corresponding z-score is equals to negative 1.645. So why is it negative? Because it is on the left side of the 0, right? So I will reject the H now if the z-score less than negative 1.645. So question say using this test statistic, right? So since the z-score value equals to negative 1.807 and compare with the critical region, it is smaller than negative 1.645. Okay, do shows these steps. This is the working that we need to see. It shows that you have done the comparison. And because of this, based on what I mentioned just now, I am going to reject H now. All right, why? Because the z-score, the test statistic, is less than the significant level. That means less than the critical region we have determined just now. So there is sufficient evidence at 5% significant that, what is that trying to test? The pollution in water is restricting growth. That pollution all right. So we rejected H now, and in our H1 is suggesting that the length of this salmon fish is less than 65. So, which means that restricting growth. All right, so this question is a left tilt test as well, but the working slightly different from the previous questions, right? Because the test statistic is given, like part 1 requested you to get the sample size, then only followed by testing. Okay, so that is what I want to discuss for this left tilt test. And that's all for this lesson. Do subscribe to the channel and like these lessons. See you in the next. Bye.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.